Hello, PreCalculus. We're going to work on graphs of nonlinear inequalities and solving some absolute value inequalities. This should be mostly reviewed from Algebra 2. We're going to bring into it this families of graphs stuff that we did in the last video. The first thing you're going to want to do here is graph the boundary line. So graph the equation, if you turn that into an equal sign, what this equation would look like. It's strictly greater than, so you'll graph it as a dashed line. Remember from yesterday, adding 3 before squaring is going to move that parabola to the left 3. Subtracting 5 after squaring moves it down 5. So my center point is at 3, negative 5. And then I put a couple points to just guide my graphing. You can do it in the calculator or plug some values in. And then I made a mistake and had to restart. So to figure out where to shade, it's above. So honestly, I would say this area in here is above. But if you want to be sure, pick a point that is clearly either inside, clearly on one side or the other. This is negative 3, 0. So I'm going to plug that into my inequality and see if it's true. Is 0 greater than negative 3 plus 3 squared minus 5? Is 0 greater than 0 squared minus 5? Yes. So if it's true, we want to shade the region containing that point. So basically, the graph for this inequality, the solution set for this inequality, is all the points inside there. Any point on the boundary curve, this does not make it true because this would be an or equal to. But inside, that is true. Again, the parent function is absolute values. That would be, our usual v. This moves it to the right one, so the center would be here. So this moves it right 1. This moves it up 4. So my center point is going to be at 1, 4. It's an or equal to, so I can make a solid line. So all we've done is taken the absolute value function and moved it right 1 and up 4. And otherwise it's exactly the same. Less than or equal to, I would shade below, but just to check, let's see about 0, 0. Is 0 less than or equal to absolute value of 0 minus 1 plus 4? Yes, it is. So we shade on that side. And on that side, in this case, means everywhere that isn't basically inside that absolute value v. Solving absolute value inequalities. When I was teaching Algebra 2, what I said about this was essentially you want to treat these like prison bars. Before we bring them down, we're going to evacuate the area. So that means we are going to move this 2 to the other side. So we've got absolute value of x minus 3 is greater than 9. Now, we take these 2 bars and we make 2 different cases. The deal is, if the absolute value is greater than 9, that means the number inside there is more than 9 steps away from 0. So it's either greater than positive 9 or less than negative 9, but more than 9 steps away from 0. So we set up the 2 cases to be either x minus 3 is greater than 9, just like it says, or x minus 3 is less than negative 9. So this is the case where it's positive, and this is the case where it's negative. And then you solve from there. So x is greater than 12, or x is less than negative 6. If you wanted a number line, well, it'd be a big number line, but. So values that are greater than 12, values that are less than negative 6. The AccuData company makes compact discs measuring 12 centimeters in diameter. The diameter can vary no more than 50 micrometers. Right now it's the value inequality to represent the range. So the size of the actual disc, we'll call it D, is the actual diameter. Sorry, I just said D, didn't I? X will be the actual diameter of the produced disc. So if we want to find out how far away from 12 it is, so we could say x minus 12, or we could say 12 minus x. We don't actually care if x is bigger or smaller, we just care by how much. So to deal with that, we just say the absolute value of x minus 12. So whatever that is, whether it becomes positive or negative, it has to be less than, oh wait, no more than, so less than or equal to, it can be 50 micrometers, it just can't be any more. 5 times 10 to the negative third. Now the reason I use this is the 12 is in centimeters, so I need to keep the same units. So x minus 12 is less than or equal to 5 times 10 to the negative third. So to find the largest and smallest acceptable diameters, x minus 12 could be less than, let's go ahead and do this, 1, 2, 3. Or x minus 12, less than or equal to, greater than or equal to negative 0.005. So once, just like it says, but drop the absolute value bars. Once, turn this around, negate this, and then solve. So x less than 12.005, greater than or equal to 11.995. So basically, x could be any number between 11.995 and 12.005, which, in retrospect, is obvious from how it said this. But, you know, occasionally we give you problems where you could do it with your common sense, and that means you can use your common sense to check your math. Guided practice, checking whether or not it's a solution. So we're going to take this, we're going to plug in our x and y, see if it's true. So is negative 3 greater than or equal to, I use this to say, is it? I don't know yet. Negative 5 times negative 1 to the fourth plus 7 times negative 1 to the third plus 8. You can do this in your calculator, of course, but I'll go ahead and do it. Negative 1 to the fourth is positive 1. So negative 5 times positive 1 is negative 5. Negative 1 to the third is negative, so 7 times negative 1 is negative 7. Is negative 3 greater than or equal to negative 4? Yes. So this ordered pair is a solution for this inequality. Is 3 less than the absolute value of 3 times 0 minus 4 minus 1? Let's find out. Is 3 less than 3 times 0 is 0, 0 minus 4 is negative 4. The absolute value of negative 4 is positive 4. Is 3 less than 4 minus 1? That is 3 less than 3? No. Be careful about this, because if that were an or equal to, sure, yeah, 3 is less than or equal to 3, but it's not less than itself, so this is not a solution for that inequality. Graphing again, the x cubed, remember, and adding within the parentheses moves it horizontally the opposite direction of what you expect. So 1 to the left, this is an or equal to, so it's going to be solid. And I go like this. And I go like this. And then, below. Well, this is the only side that has a below. But if you want to go ahead and plug a point in, you can. Let's go with, let's go with the one that turns out false. So negative 3, 1, let's say. Is 1 less than or equal to negative 3 plus 1 cubed? Is 1 less than or equal to negative 8? No. So we shade the side that this negative 3, that this point is not on. So we're going to shade everything on this side. There we go. And you can do this in your calculator as well. It's just, you should know how to do it by hand. Okay, here's a nice one. So it's going to be a parabola. It will move right 3, so the center will be at 3. But it's going to be expanded vertically by a factor of 2. So it'll be taller. So instead of going up 1 over 1 for its first point, it'll go up 2 over 1. And then instead of going 1, 4, it'll go, 2, 4, it'll go 2, 8. So it's going to be steeper, but it'll still have the parabola shape. This is going to be solid because it's an or equal to, and we are less than or equal to, which means everything that cannot be said to be above this line somehow. So everything that's not inside of there. Whew, pretty one. Okay, absolute value of x minus 4. Oh, darn it. The minus 4 moves it to the right 4. The negative flips it over. So instead of being a v upward, it'll be a v downward, centered at the same place. And then finally move it up 2. So, and it's going to be a dashed line. So, dashed line this way, greater than, so above. Solving inequalities, once just like it says, once the opposite and negate it, once just like it says, once the opposite and negate it. Even if it has an x on both sides, this still holds true. So subtract 3x, subtract 3x. Negative 4 is less than or equal to negative 2x. Turn around the inequality. 2 is greater than or equal to x, or if you like, x is less than or equal to 2. Subtract 3x, subtract 3x. Negative 4 is greater than or equal to negative 4x. Turn the inequality around. 1 is less than or equal to x, or if you like, x is greater than or equal to 1. So, 1 is less than or equal to x is less than or equal to 2. Oh, sorry about that. And for this one, just go ahead and finish it up. X is greater than negative 2. X is less than negative 10. This is not an and. You can't say x is both greater than negative 2 and less than negative 10. So you just join them with an or. X is less than negative 2, sorry, greater than negative 2 or less than negative 10. Less than negative 10, greater than negative 2. There you go.